Okay, let's talk 11.6. So in 11.6, I'm going to introduce you to a new kind of graphing system, a new kind of set of equations. So like all of our graphing that we've been dealing with trig and then like what you dealt with in college algebra, these were all rectangular coordinates. There was an x and there was a y. So what we're going to be talking about in here is polar coordinates and polar equations and polar graphs. This is what a polar graph in kind of coordinated system looks like. So it's all circles, and along this line right here, this represents the radius. And then out here, you'll be turning the amount of the angle that you need to turn. Okay. So it's just like when you guys were creating angles in a standard position. That was kind of a horrible line. How you would have your initial vector along the x axis, and then you would rotate out that angle measure. Standard position is a lot like this, except in standard position we were in a rectangular coordinate plane, and here this is actually polar coordinates, which makes sense that we would be moving that angle. Okay, so a couple things that I want you to know about polar coordinates. It's all based on a point called a pole. So that's like how far out like the radius of this kind of like so-called circle will be. Okay, an array called the polar axis, and the ray that moves out, that angle measure, that theta, is uh that's telling you where your polar axis is going to end. So these points look like this. R, that's the pole, comma, theta. That's how these points are all written up. Okay? So let's start talking about polar coordinates, and we're just going to work with uh, the r comma theta in parentheses first and convert between it to rectangular, or we'll also convert from rectangular into polar. Um, and yeah, we'll do some good work there. Okay. And yeah, let's get started. So here I've given you a polar coordinate. How do I know? Because we've got a pole, and this thing right here is in radians. Okay. Or not, sorry, not radians. It's in degrees. Most of what we want to work with is in degrees. So you're not going to have to worry too much about radians, but they do occasionally throw in radians for you. So make sure that you keep an eye on that. All right. So, first things first, let's talk about how we would plot something like this. Okay. So, if I come back here, let's just grab this graph, copy. Okay. See if it'll let me bring it up. Oh, edit and paste. All right. So, what you need to do first, if you're going to plot this, you're going to think of this -7 right here. You need to think about it as a positive. So what we're going to look at first is we're going to plot this as like a 7 comma 120 degrees. I'll tell you how the negative works here in just a second. So 1, 2, 3, 4, 5, 6, 7. So here is what kind of like the pole looks like. It's 7. And then we're going to rotate out 120 degrees. Okay? So 120 degrees for us. If we convert that to radians, since my polar graph is already in radians, I believe that is The 2 pi over 3, but let me double check. Yep. So my graph will end right there because this angle right there is 120 degrees. And actually, it should have been stretched all the way out to 7. I shouldn't have stopped it there. Actually ends right there. So that's what 7 comma 120 looks like. But how do I deal with the negative? That's why we talked about vectors first. So with vectors, remember an opposite vector just flips it across from it. So this picture that you see right here, that I'm going to highlight in green, that is the true polar coordinate picture of -7, 120 degrees. So if you have like a negative pole here, what you need to do is interpret it as a positive, rotate out that degree, and then again, just think of this as a vector and give me the opposite vector to it. So the green is the one that you would look for. And there will be 4 pictures, and you just select the picture that matches it. Now, the other things, again, like I said, they're going to ask for, they're going to want you to convert this to rectangular. So in order to convert to rectangular, we have 2 formulas that you're going to work with. X is equal to R cosine theta. Y is equal to R sine theta. So if I want to make the polar coordinate for this, -7, 120 degrees, all I got to do is just plug in my information. The x part of the coordinate will be -7 times cosine 120 degrees. The y part will equal -7 times sine 120 degrees. So you just use your big chart of angle measures, which I've given you, and cosine of 120 degrees is -1/2. So we're going to multiply those two together, which gives us 7/2. And sine of 120 degrees equals square root of 3 over 2, which will give us -7 square roots of 3 over 2. Okay? So the polar coordinate for this guy is 7/2, comma, -7 square roots of 3 over 2. And they do want it exact. So you got to make sure that you have this information. Now, some other things that I want you to know, and they will also ask you about these questions, is they want to know what are some other polar coordinates that will match up with that. What are some other polar coordinates that will give me this same angle? Okay? Well, again, we're just going to jump right back into the idea of coterminal. Okay? So we can give you 2 coterminal angles. I spelled that wrong. Coterminal polar coordinates. Let's call that. And again, remember that coterminal means all we're going to do is take our angle and add or subtract 360. Or if it's in radians, 2 pi. Okay? So, two coordinates that also match up with that same green angle I had above. Well, all we got to do is take 120 plus 360. So -7, comma 480 degrees matches. Or take 120 minus 360, -7, comma -240 degrees match. Now, there are two other polar coordinates that you can give me that we're going to talk about. They're kind of like coterminal, but they're going to be dealing with the positive version of our angle, because there's a way to take this there's a way to take this positive coterminal angle here, the one that's not the opposite, and make it match up with this guy that's down here. So using the positive coterminal angle, or well, sorry, not coterminal, but using the, oh man, I don't want to say positive because sometimes it's not positive. In this case, it's positive. So let's just say using the opposite. So to opposite, quote unquote, coterminal, because it's not really coterminal, polar coordinates. All right. So these points, because we're going with the opposite, our original was a -7, so the opposite is a +7. What you do in this is you take the angle plus 180 degrees or minus 180 degrees. Because again, that makes sense because this angle right here, in order to get this ray that was right here onto the green ray right there, that's a 180 degree rotation. Okay? So that makes sense why we would add 180 degrees to it or subtract 180 degrees to it. Okay? So 120 plus 180 gives us 7, 300 degrees. Okay? Or 120 minus 180 gives us -60 degrees. So there are 4 ways of coming up with other polar angles that would match up, okay, to my green angle that's up there. And some of them are going to ask for those kind of angles, okay? And again, if it's not adding or subtracting 180, if it's in radians, it'd be pi. Okay? All right. So I've got 2 problems right here. Go ahead and pause the video and give them a shot. Okay. So let's start finding some information. So again, I'm just going to come over here and I'm going to grab my polar coordinate, copy, and paste. There's for that one. And paste. All right, there we go for this one. Whoops, went right back down. Okay. So to plot this, we're going to go out 3. So we got here 1, 2, 3. And then we're going to go negative 210 degrees. So that's going to go clockwise. So negative 210 degrees. Let's see here. Just converting this into radians real quick. That will give us a negative 7.6, which, so let me see something here. 7.6, so negative 210. Negative 7.6 should be right here. Make sure I'm writing this time. 3. Why are you not writing? Come on now. There we go. Now we're writing. So it should look like that. Okay, this guy is a negative 7.6. So that's our angle. Because again, this angle rotated that direction 210 degrees. So that would be the picture you're looking for. Okay? So if we turn this into rectangular, well, x is going to equal r cosine theta. Y equals r sine theta. So if we plug in, r is 3 cosine negative 210 degrees. Y is equal to 3 sine, we'll just put that in parentheses, negative 210. Okay? So what we have here is 3 times negative 210. Cosine would be negative 3 square root of 2. Sorry, negative square root of 3 over 2. And the sine of 210 would be, sorry, just looking over my chart, 1/2. Yep. This is equal to 3 times 1/2. So our polar coordinates would be negative 3 square roots of 3 all over 2, comma, 3 over 2. There's the polar coordinate. Or sorry, the rectangular coordinate. I'm going to come back here and check something real quick. Okay, so I did it right. I thought I might have put the wrong radical on the previous one. If I want to find 4 other points that match, well, remember we could do coterminal real quick. And so we're going to keep this angle the way it is. So using the original polar coordinate, so using the original 3, since I'm going with the original r value, this is the real coterminal. So all we're going to do is add 360 to this. So negative 210 plus 360. So another point that yields that same picture you just see over there is 3 comma 150. So if I take negative 210 and subtract 360, I get 3 comma negative 570 degrees. If I use the opposite pole, so negative 3, all I'm going to do is take this angle and add or subtract 180. So negative 210 plus 180 gives me negative 3, negative 30. Another one will be negative 210 minus 180, which gives us negative 3, negative 390 degrees. And there you go. This is all that they want you to do. They want you to be able to find the picture out of 4 pictures, and they want you to be able to provide some coterminal points, okay, that produce the same polar graph, and give us the rectangular point. Nothing crazy, right? So on this guy, so first things first, we need to work with the opposite of this. So we're going to plot this first and then take the opposite of the pole. Okay? So 1, 2, 3, 4, 5. So we're going to rotate pi over 6. 1, 2, 3, 4, 5. But I need the opposite pole of this. So that gives us, I probably should have did that in a different color. Let's do that. Well, let me just highlight it then. So here's what our graph really looks like. So that purple graph is the negative 5 pi over 6. Okay? So now we need to, let's go ahead and find the coterminal ones. Okay? The ones that give me the same purple graph. So if I keep the negative 5, this is the one where we add or subtract because I'm keeping the original pole. We're going to add or subtract 360, or in our case, 2 pi. Okay? So I just go to my calculator, 1/6 plus 2, because it's like adding and subtracting fractions. We know that. And we get 13 pi over 6 if we add the 2 pi. And if I take 1/6 minus 2, we get negative 11 pi over 6. Oops. Crazy 6. Okay? Now if I go with the opposite pole, so this is where we are adding or subtracting 180, or in our case, pi. So if I take 1/6 plus 1, 5 comma 7, 6 will give us the same graph. If I take 1/6 minus 1, 5 comma negative, and this should be 7 pi over 6, and we'll get negative 5 pi over 6 for that guy. So there's all your so-called kind of like coterminal points that will yield the same graph. And then if we want the rectangular, well, all we do is follow our formula. X equals R cosine theta. Y equals R cosine theta. Okay? So plugging in, our R is -5, and we're going to take cosine pi over 6. And then we got -5 sine pi over 6. Well, we're going to take -5, and cosine pi over 6 is square root of 3 over 2. Sine pi over 6 is 1/2. So we end up with the following rectangular point. We get -5 square roots of 3 all over 2. And we get -5 halves. Okay? Other questions they might ask is they might ask what quadrant are you guys, is this polar coordinate in? So again, it's got the same quadrants. Over here is quadrant 1, quadrant 2, quadrant 3, quadrant 4. Just look at your graph and you'll know what quadrant it's in. It's not meant to be a mind-boggling question. Okay? So, there are those questions that they're going to ask you. So that right there pretty much kind of covers half of this section. So let's talk about the other half. So now we're going to go backwards. I think I got 2 of these. Yeah. So let's go backwards. This time I've got the rectangular, and I want you to go back to the polar coordinates. Okay? So let's talk about how we do that. All right. So we have 2 other formulas that are going to help us out. We have a formula that says R equals the square root of x squared plus y squared. Because this relates back to right triangles, it's just the Pythagorean theorem. Or in other words, it's the radius of a circle with the center at 0, 0. Okay? So that's where this formula is coming from. And it makes sense. Okay? Because this R represents radius. So it's just the radius of a circle with the center at 0, 0. And then another one that we have is that tangent theta. Well, you know how to find tangent theta. It's equal to y over x. Again, like a right triangle. So now we can find our theta and our r. All we have to do is just plug in what we know. Okay? So to find r, we're going to take r equal to, we're going to have 7 my mind is not working this morning, squared plus -7 squared. So 7 squared is 49. -7 squared is 49. And 49 plus 49 gives us 98. And you do have to reduce this radical if it can reduce. No decimals. Okay? And so this does reduce with the square root of 49, square root of 2, and that gives us 7 square roots of 2. So that is our R value. To find the theta value, tan theta equals our Y value, which is -7, all over our X value, which is 7. Or if you really wanted to simplify that down, and what you're looking for is tangent theta equal to -1. So we want to know, when is tangent theta equal to -1. Because in order to get theta by itself, we run that inverse trig. Tan -1. Tan -1. So theta is equal to whenever tangent is -1. So if you go to your list and you look through, when is tangent -1? Well, we've got two answers for that. We've got 3 pi over 4 and 7 pi over 4. 3 pi over 4 and 7 pi over 4. Okay? Any questions so far? All right. Now, how do I know which one of these I need to work with? Well, with tangent, if you remember back from that chart that I gave you, the region for tangent is, and I gotta get into my notes and look that up real quick because I don't remember off the top of my head. I'm not that good. Almost there. There it is. Tangent is in the quadrants 1 and 4. So you do have to go back to this. So when you run the inverse, you got to make sure that you look at the quadrants for tangent, and it will always be tangent that we run. So we're in quadrant 1 and quadrant 4. Well, 3 pi over 4 is not in quadrant 4, or 1 or 4. So this guy gets thrown out. So in the end, we're only going to work with 7 pi over 4. Okay? So our final solution for this is 7 square roots of 2, comma, 7 pi over 4. Or if they want this in degrees, 7 pi over 4 is 315 degrees. Okay? Now, they might ask for some other, again, quote unquote, coterminal. So basically, what they want is they want the opposite. Okay? They want the opposite. Now, in here, the directions also tell you that when you're working with these, they only want answers between 0 and 360 degrees or 2 pi. Okay? So if I take 315 and add 180, because I'm working with the opposite, that's over 360 degrees. So we don't want that. But if I take 315 minus 180, that gives us 135 degrees. Okay? Or in radians, 135 degrees is 3 pi over 4. So that 3 pi over 4 that we threw out earlier, it's not for the original angle. It's actually for the opposite angle. Okay? And there you go. So these are some things that you can do. Once you get the polar coordinate for the original one, then go ahead and find the polar coordinate for the opposite one and keep it within the range that they give you. And it will always, the range should be 0 to 360 or 2 pi. Okay? So go ahead, pause the video, try that again. Okay. So r is equal to square root of -11 squared. plus 0 squared. So negative 11 squared is 121 plus 0 squared is 0. So that gives us the square root of 121, which is 11. Easy enough. Tangent theta is equal to 0 over negative 11, which, in other words, all we're working with is tangent theta equal to 0. So we're going to run inverse tangent. And so, in other words, we want to know when is tangent equal to 0. So theta is equal to, tangent is 0 at 0 degrees, 2 pi, and pi. Now, remember what I said about tangent? Tangent, we only care about when we are in quadrant 1 and quadrant 4. So, this pi angle, we're going to throw out. And we're going to keep the 0 and the 2 pi. Because 0 and 2 pi are both the same for us. So, our polar coordinate is 11, comma, 0, or 11, comma, 2 pi. And again, in these directions, they want us to be between 0 and 2 pi, or in other words, 360. So if I find the opposite pole, all we're going to do is add or subtract pi from this, as long as we are in theta, or add and subtract 180. So if I add 180 or add pi, I get pi. Same thing over here. Again, I can't add pi because that gets us over this. I can't, but I can subtract it, which brings us back to pi. Again, if I add pi, that brings us to pi. If I subtract pi, that takes us out of the range. So these all are answers. And again, if you need the degrees, that's 180. If you need degrees for 2 pi, know that that's 360 degrees. And there you go. All right. So now, there's the first half. Sorry, I thought we were done with the first half. I forgot that we had to reverse it from rectangular to polar. So here, what I want to introduce to you is what these graphs kind of look like. You know, polar graphs are pretty interesting. Let me bring up our calculator, because when you're dealing with polar graphs, you need to make sure that your calculator is in certain modes. Okay, I want to show you some things too. So first off, you can see that our calculator is in, well, if you click on mode, you can see that our calculator is in functions. Okay, so what we want to do, if you look right over here, there's polar. So you can convert your information, if we scroll down in the calculator, to make it functioning as polar. And what's really cool, if you click y equals, which is where we're getting at, notice it's no longer y equals, it's all r equals, r equals, r equals. That means you're in polar coordinates, and that's important for us. Okay? Other things, if you hit second in math, second and apps. This R stuff information right here, this is rectangular to polar. Rectangular to polar. Okay, so this will take your rectangular information and convert it into R. This will take your rectangular information and convert it into polar. Okay. And then this will take your polar information, convert it into rectangular. This will take the polar and convert it into rectangular. Okay. So I'll show you some things. It's really kind of cool. So if we go back and hit second apps, I'm going to change my mode back to function. It really doesn't matter what you're in because the information runs the same way because it's all about converting in the background. So if I go down here and let's say I want to find the polar coordinate for that negative 11 comma 0, I'm going to put negative 11. This is where that comma button right here by the parentheses comes involved. And then you'll hit 0, close up the parenthesis, hit enter. So there's the R that we found. If I want the theta, we're going to be in degrees right now, so it will kick it out in degrees. So I'll hit apps, scroll down here to the theta, and then again I put the negative 11, hit comma 0, and this one actually gave us the negative polar version of it. Okay, so there you kind of got some information. So there you go. There's that. Yeah. All right. So then from here, you could also do, like those beginning problems that we did, that negative 7, 120. You can go to second apps and we can take and convert to rectangular. So if I go down to number 7 and I put in that negative 7 and we're in degrees, so make sure that your angle's in degrees, 120. That gives us the 3.5 that we came up with, which is that 7/2. Okay. Now, unfortunately, it will not give you the exact answer if there's a radical involved. It will give you the decimal version of it. I'll show you that real quick. So if we hit second apps and we choose number 8, again, if I put that same information in, negative 7, comma, 120, and I don't have to put the degree symbol on it because it already knows we're in degrees. If it was radians, if you were working with the radians, I would just I would put this back in radians to deal with it. So like I said, see, it's going to give you the decimal version of it, which is the same as what we found with the negative 7 square roots of 3 all over 2. See, the same. It just won't give you the exact answer if there's a radical involved. But pretty cool to know that we can do that. All right. But again, going back to what we were talking about. So if I come back in here with the circle, so this is what a circle looks like in polar coordinates. It says the radius equals whatever A is, and A is the radius. R equals a plus or minus A. You either have a positive A or a negative A. Okay, I know it seems weird with a negative radius, or a negative A, but again, remember that just means opposite vector. Okay, or opposite pole. So if I come in here to my calculator and I make sure that I'm back in polar coordinates, so I go right here and let's just make it easy. Let's make it a radius of 2. And we hit graph. Okay, so notice it's weird. My graph didn't come up. What happened? Well, that's where we got to go into zoom and we got to change what we're in. We are in polar coordinates this time. Okay, I believe it was in zoom. Yeah, it is in zoom. And since we're in polar coordinates, right now my table is set for rectangular coordinates from a negative 10 to a positive 10 in all the directions. So if I need to fix that, we need to go to zoom fit. Okay? Zoom fit. And if I hit zoom fit, well, there's that. Sorry, I'm so off. Maybe it's Zoom Standard. Zoom Standard. There it was. You got to go to Zoom Standard because that standard means that it's going to put it into polar coordinates. Now I'm remembering. So again, if you go in here and when you put in your equation the first time and you go straight to graph, it's probably not going to graph because it's in a polar coordinate window. But when you go to Zoom and you scroll down to standard and click it, it's putting it in a standard polar window. See, look, we'll go to see how now this is a standard polar window because before it was from -10 to +10 going by 1, -10 to +10 going by 1. See, it was really weird. It didn't know what to do. Okay. So when you hit Zoom Standard, it fixed all that information for us. Now I know that doesn't look quite like a circle. Okay. If you really want it to look like a circle, go to number 5, Zoom Square. And now it really looks like a circle because it's adjusting the window to make it look exactly as it is. But really, Zoom Standard is where I would go. See, and notice that it's a circle with the origin as the center of it. Cool? Yes. Good. I'm glad you agree. All right. So whenever you have an equation where it's r equal to a number, it's a circle. Our next one is the rows. Okay? Yeah. So our next one is the rows. So if you have r equal to a sine n theta, or r equal to a cosine n theta, you have what is called a rose. It looks like a flower. Okay? Now, what's cool about the flower is A is the length of the leaves. How long is your petals? Okay? So this tells you how long it is, kind of like, again, it's like a radius. And then if n is odd in here, that means you will have that number of leaves. So if n is 3, that means I will have 3 leaves. If n is 5, that means I will have 5 leaves, 5 petals. If n is even, then you will take that number times 2, and that will be the number of leaves you have. So if n is 2 in here, that means I will have 2 times n number of leaves, which is 2 times 2. I will have 4 leaves. If n is 4, I will have 8 leaves. Okay? So let me show you what this looks like. So let's just keep it as a radius of 2, and let's do cosine 3. And now if I hit my x value, notice it comes up as theta. So instead of putting x's in here, because you don't put x's, you put in theta. Okay? So if I hit graph, see, look, this is what they call the rows. And the length of my petals are 3. Okay? And there were 3 of them. If I go back in, show you what happens if I change it to an even. So let's call it 2. So I should have 4 petals. And there it is. Again, all of these are length 2. I think I said length 3 a second ago, but they're length 2. All right? So that's what cosines look like. Notice with cosine, it starts on the x-axis on the positive side. Okay? Now let me show you what happens if we change it to sine. So cosine, the graph really does start on the x-axis on the positive side. The first leaf will always be on the x-axis on the positive side. If I change it to sine, look what happens. Notice it doesn't touch the x-axis. Okay? Technically, my first leaf is in the first quadrant right here. And the same thing if I convert that to an odd. See, my first leaf is in the first quadrant. Okay? So that's kind of the big difference between these. When you're dealing with sine, you will start off of the x-axis when it designs it. So you should see a leaf in the first quadrant. When you have cosine, it starts on the positive side of the x-axis. Okay. The next one is called the cardioid, which in other words means heart, as in cardiovascular. Okay. So here's what the heart equation looks like. So a parenthesis 1 minus cosine theta parenthesis, or you could actually take this a and distribute it through. And the same thing over here, a parenthesis 1 minus sine theta. Or again, like I said, you could distribute it through. Okay. So let's go up there and I'll show you what a heart looks like with both of these versions. We'll talk about the difference between them. So we've got 2 minus 2. Let's go sine theta. So that's a cardioid. And there it is. It looks like a heart. Okay? So sine, your heart is facing up. Okay, which makes sense because sine is like all about the y values. So your heart is facing up. If I change it to cosine, notice my heart is facing sideways. Because again, cosine deals with x values. So that makes sense. So that's the difference between those. Okay? If it's cosine, your heart is facing sideways. If it's sine, your heart is in the upright direction. Okay? Last one that I want to talk about is called the lemniscate. And you can see that it says r squared equals a squared sine 2 theta. R squared equals a squared cosine 2 theta. So in order to put something like this into the calculator, you'd actually have to take the square root of both sides and show you what the lemniscate looks like. All right, so the lemniscate looks like this. Come in here. Now you actually have to do 2 of these in order to make it because you're going to take the square root of both sides. So that means you're going to have a positive squared piece and a negative squared piece. So let's just say a is 2. So that means we have 2 squared, which is 4. And make sure I put in the correct. So sine 2 theta. But again, I got to have another one of these because I took a square root of both sides and you use plus or minus. So this time I'll have the negative square root of that version because I need both. Again, my a was 2, so 2 squared is 4. Sine 2 theta. Here's what it looks like. And there it is. Okay. So it looks like kind of like a rose, but it only has 2 petals. Lemniscates only have 2 petals. Okay. So notice sine kicks you out into the first quadrant and the third quadrant. If I go back, change this to cosine, here's what happens. Cosine, notice it puts me on the x-axis. Okay? So there you go. Now you know that you can put all these equations that you get into the calculator because what's going to happen in your assignment is they're going to say, okay, here are some equations, tell me what they are, and then pick out the graph for it. That's not too hard. Just go to your calculator, let it do its job. Okay? So one more thing I want to talk about, which is down here. There are 2 other ones that we could talk about. The lemnicons kind of look like a heart, but sometimes they it'll like curve on the inside. So it'll look like this. It'll start out looking like a heart, and then it'll come around and it'll curve on the inside like this. Okay? So that's kind of the lemnicons. They do a little bit of extra curving and things like that. Okay? So just to kind of give you a heads up on that. All right. So limicons, these are their equations, and Archimedes spiral looks like this. Okay, and again, it's a spiral, so it'll start in the middle and work its way out and around and around and around. Okay, I just wanted you to have a little note about these, so that way, you know that these things do exist. Okay. All right, so again, back to this. So here I have 5 equations. I want to know what are these equations. Okay, and then again, all of these you can go into your calculator and put in. Again, for this guy, the r squared, in order to put this in the calculator, you got to put a square root of it. And there's going to be 2 of these that you put in, a positive square root version of this and a negative square root version of this. Okay, so let your calculator help you out with the graphs for these. But what are they? Go ahead, pause the video, and tell me what they are. Okay, so if we look at this guy, hopefully you told me that this one right here, the answer is a circle. Correct. Yay. Hopefully for the next one, you told me that this is a rose. Okay. And again, for this guy, that means this is a circle with a radius of 10. So you count out 10, make your radius all the way, or make your circle all the way around. This one, my petals have a length of 4. And because this is even, I'll take 2 times 2, which is 4. So that means I will have 4 petals. And since this is cosine, my first petal will actually start on the positive x-axis side. So just looking at this and what we talked about, I know that that's going to happen for this guy. Okay? This one right here, hopefully you said this is the heart, the cardioid. See, it's got that same format. A, same number. Look right over here, 12, same number. Cardioid. Okay. And again, you can go into your calculator, graph that. But what about this guy? What is this? If you weren't sure, just go to your calculator. Clear this out. Clear this out. So 1 plus sine theta. Oh, it's a cardioid. Okay. It's a cardioid. So if you didn't know that, you could talk about that. So this guy right here, again, just another cardioid. Now you're probably like, well, there's not another number. Yes, there is. What number's in front of the sign? There's a 1 there. Okay. All right, and the last one, hopefully you recognize this as the lemniscate. Okay. So if we type that in, this guy is the lemniscate. All right. So there we go. Again, in your assignment, that's all they want you to do. They're going to say, here's an equation. Tell me, what is it? Okay. And then tell me what kind of graph it is. All right. Any questions? Okay. Last but not least, we're going to be converting equations into rectangular and into polar. Okay. So we're going to make those equations that we talked about. All right. So we want to take this and convert it to polar. So on that previous page that I have right here, these are all those formulas that we talked about earlier. I'm just bringing them back for our reference because these are the only things that we're going to use to help us out. So over here, I want to convert this into polar. Well, what do we know about x and y? Well, we know that x is really r cosine theta. We know that y is really r sine theta. So we're going to just exchange the x for r cosine theta, and we're going to exchange the y for r sine theta. So x is now r cosine theta minus the y is r sine theta, and this is all equal to 3. So for polar equations, they all have to be r equals. So now that we've got r in here, we've got no more x's and y's. All we have to do is get r by itself. Well, again, what do both of these terms have in common? They both have r. So pull that out as a GCF, and you're left with r cosine theta minus sine theta equal to 3. I pulled out that r as a GCF. Well, how do I get rid of multiplication between these two? We're going to divide by cosine theta minus sine theta. Divide by cosine theta minus sine theta. So now we know what r is, and it is that simple for this guy. R is equal to 3 over cosine theta minus sine theta. And that's the equation they want. Okay? So, do it again. Give this one a shot. Pause the video and go. Okay. Again, remember that we can change x and y for their polar equations. So that gives us r cosine theta, and we're going to square this, plus r sine theta, and that needs to be squared, equal to 49. Well, let's do some squaring real quick. R cosine theta squared is r squared cosine squared theta plus r sine theta squared is r squared sine squared theta equal to 49. So again, just like what we did last time, what do both of these have in common? We got to get the r by itself. They both have r squared. And then we have cosine squared theta plus sine squared theta equal to 49. But wait a minute, Mr. Armstrong. Don't we know something about cosine squared plus sine squared? Yes, you're absolutely right. We do know what cosine squared plus sine squared equals. Remember, that's that Pythagorean identity that we dealt with so much in chapter 10. This right here is really just 1. So you have r squared times 1 equal to 49. But what's r squared times 1? That's just r squared. How do I get rid of something squared? Square root it. And because I'm square rooting, this is plus or minus 7. And that makes sense that this equation is in the form of a circle, because up here, this is the equation of a circle with the center at the radius, or with the center at the origin and a radius of, well, r squared is 49, so r is just 7. So that makes sense that this is the final equation in polar. because all you were doing is converting this to a circle equation in polar coordinates, which a circle is just r equal to plus or minus your radius. Okay? All right. Now we're going to take it backwards. I've got two more. Okay? So I've got this and another one, and we're going to go back to rectangular. Okay? So we're in polar now. All right. So going back to rectangular, kind of going to give you a hint here. In order to go backwards, sometimes it helps to multiply both sides by r. So keep that in mind. Because right now, I mean, there's really nothing I can do. I mean, we could try and divide by cosine theta on both sides, but I don't have any equation that helps me get rid of r over cosine theta. I mean, this piece right here, give me a second. This piece right here almost looks like we could have something with, if we just had an r in front of that, I could convert that into x. Okay? If I just had an r in front of this. That's why I say, I give you that note. Sometimes it helps to multiply both sides by r because I can force an r in front of this in multiplication. So if I multiply both sides by r, this gives us more to work with because what's r times r? R squared. And I have a formula for r squared. If I multiply this side by r, the 6 cosine theta, I get 6 r cosine theta. And I know what r cosine theta is. So if we substitute in our rectangular pieces, r squared is really just equal to x squared plus y squared equal to, we know what r cosine theta is. That's x. So if we move this x, 6x, over here, this is what we're looking at. X squared minus 6x plus y squared equals 0. So here's our equation, okay, in rectangular coordinates. Now, unfortunately, even though this is acceptable for me, it's fine. I know what it is. Unfortunately, you guys are going to have to do some completing the square because really what you're looking at here, this is a circle equation, okay, but it's not centered at the origin anymore. So this equation is a circle. And what you have to do is we need to complete the square on this part. Remember, in order to complete the square, we got to find the new c. Let me go ahead and change the color since we're going to talk about this. To complete the square, we got to find the new c, which is b over 2, and we're going to square that. So our b value in this is -6. So c is equal to -6 divided by 2, and we're going to square that. Well, -6 divided by 2 is -3, and if we square that, we get 9. So what's going to happen is we're going to add 9 here, and if I add 9 to that side, I've got to add 9 to the other because I'm forcing in a +9 to complete the square for this. And remember, complete the square allows us to turn something into being factorable. So this guy is factorable, and if you factor that, this is what you should end up with: x minus 3 squared. That's what this factors into. plus y squared, and 0 plus 9 is 9. Because again, this is an equation of the circle, where if you found the center of the circle, it's at 3, because I take the opposite of that number. This guy doesn't have a number with it, so that's 0. And the radius of the circle, take the square root of 9, is 3. So this is really what they're after. That's the polar equation, or the rectangular equation they want. You had to do a little bit of completing the square after you've got it converted. And technically, I don't know why I boxed in the radius in the center. They don't really want to know that information. They just want the equation. That's what's going to make them happy. All right. So there you go. One last one. Go ahead, pause the video, give this a shot. All right, let's finish strong. Here we go. So for this guy, let's get this cosine stuff out of the denominator. Okay? So let's go ahead and think of this like a proportion. This is over 1, and do some cross multiplying. So we're going to take r times all of that. So that gives us r minus r cosine theta. Oh, look, we know what some of this stuff is. Cool beans. And what's 1 times 3? 3. Okay? So what do we do now? Well, there's some information we know over here. We actually know both of these. Remember that r squared is equal to x squared plus y squared. Or, I told you another version of this is r is equal to the square root of x squared plus y squared. Okay? We're going to use this fact right here to help us out with that r. And hopefully you recognize that, oh, I know what r cosine theta is. So let's plug in what I just talked about. This r right here is going to change into that radical. X squared plus y squared minus, horrible minus, my computer moved on me. R cosine theta is x equal to 3. Okay? Well, what we need to do now is to start thinking about, well, how can we get this y by itself? So I need to get this square root out of there. So in order to do that, add x to the other side. And that gives you the square root of x squared plus y squared. And that equals x plus 3. How do I get rid of something squared? Or sorry, how do I get rid of a square root? Just gave you the answer. Square it. Which means I also have to square that side. And that doesn't mean distribute the 2 through. That means I have 2 of these x plus 3's, x plus 3's. So you have to do some FOIL on that right side there. So what do we have over here on the left? We've got x squared plus y squared. Equal to, what do we have over here on the right? Well, if you FOIL all that out and condense down, you get x squared plus 6x plus 9. Well, let's get this y by itself. So subtract x squared. We get y squared equal to 6x minus 9. And if I wanted y truly by itself, you'd have to take the square root of both sides, and you'd say plus or minus the square root of 6x minus 9. And that would be one possible answer. This is actually one of the possible answers as well, too. This is the equation of a parabola on its side. Okay? This is an equation of a parabola on its side. Or what you could have done is gotten the x part by itself. So equations of parabola that are on their side, sideways, they open up at looking like C's or backward C's. If we get the x by itself, so this answer works. But if I take this, y squared equal to 6x. If I get this x by itself, let's go ahead and change this to a different color. Y squared equals 6x minus 9. Add 9 to both sides. So that gives us 6x equal to y squared plus 9. How do I get rid of multiplication? Divide. So another perfectly acceptable equation is x equals y squared plus 9 all over 6. Those of you that are going to be taking pre-calculus, they talk about the sideways parabola, which is what this guy is, and that. So, it's okay that you kind of didn't, hit that up. And the same thing with this guy. This guy, you work a lot with circles and writing circle equations in pre-calculus. So you'll hit all that up. And that is 11.6.